Jai Hind everyone, my name is Swati Tomar and I work as assistant professor in CSE. Today's video lecture is about threads in operating system. So what is operating, let's study about the basic internals and design principles of operating system. The basic idea is that the several components in any complex system will perform particular sub-functions that contribute to the overall function. So what is the basic idea of an operating system is that multiple components in any complex system perform particular sub-functions that contribute to overall functions. And what is the difference between a process and a thread? Now, traditional processes have two characteristics: resource ownership and scheduling execution. Process includes a virtual address space to hold the process image. The operating system provides protection to prevent unwanted interference between processes with respect to resources, and the scheduling and execution follows an execution path that may be interleaved with the other processes. A process has an execution state. Execution state can be a process can be in a running state or in a ready state, and a dispatching priority and is scheduled and dispatched by the operating system. Traditionally, processes are sequential, that is, only one execution path is there. Now, what are processes and threads? Now, multi-threading. Multi-threading, what is multi-threading? The ability of an operating system to support multiple concurrent paths of execution within a single process. Multi-threading is basically the ability of the operating system so that it can support multiple concurrent paths of execution within a single process. The unit of resource ownership is referred to as a process or task. What is a process or a task? It is the unit of resource ownership. The unit of dispatching is referred to as thread or lightweight process. Now, we also define thread as a lightweight process, and it is a unit of dispatching. Now, single threaded approaches. A single execution path per process in which the concept of thread is not recognized is referred to as a single threaded approach. What happens in a single threaded approach? It is a single execution path per process is where the concept of thread is not recognized. MS-DOS, some versions of Unix supported only this type of process. Now, this is the diagram which you can see of threads and processes. Here you can see it is one process or one thread. Here there is one process and multiple threads. One process can have multiple threads. For example, in a Google Chrome browser, you can have multiple tabs open. So, that Google Chrome running tab is a process, and the multiple tabs running inside the same browser is an example of multiple threads. Now, there are multiple processes and one thread is present per process. Now, here you can see multiple processes are there and multiple threads are per process are there. Here, this is your instruction trace. Now, multi-threaded approaches. The right half of figure 4.1 depicts multi-threaded approaches. Now, here you can see at the right half of this image, there is multi-threaded approach. There is one process and multiple threads are present, multiple processes and multiple threads per process are present. Now, in the left half, you can see there is single threaded approach, where one process is there and one thread is present. Multiple processes there are and one thread per processes are present. A Java runtime environment is a system of one process with multiple threads. Windows, some Unixes support multiple multi-threaded processes. Now, what is a processes? In a multi-threaded environment, the process is a unit that owns resources and unit of protection. In any multi-threaded environment where there are multiple threads present, process is that unit that owns the resources and the unit of protection, that is, the OS provides protection at the process level. Now, processes have a virtual address space that holds a process image. The protected access to processes is there, and other processes, files and input output resources is there. One or more threads in a process. Now each thread has an execution state. The execution states are of running, ready, etc. Running happens when the process is already inside execution state, and ready is whenever a process is ready for execution. Saved thread context when not running, TCB, an execution stack. Some per thread static storage for local variables. These are the things present in a thread. An execution state, saved thread context when not running, an execution stack, some per thread static storage for local variables, access to the shared memory and resources of its process. Each thread has access to any shared memory and the resources of its processes. Now this is your single threaded process model, and this is a multi-threaded process model. The components present in a single threaded process model are process control block, user stack, kernel stack, user address space. What happens in a process control block is that PCB is that performs the function of storing the history of, saving the history of any transaction happened in for any process. Now in a multi-threaded process model, there is a process control block, there is a user address space, and there are multiple user stacks and multiple kernel stacks, and there are multi-threads. So there are multiple thread control blocks are present. Now what are the benefits of threads? Threads take less time to create. It takes less time to create a new thread than a process. It will take much longer time duration in creating a process than it will take to create a new thread. Now less time, it will take less time to terminate a thread than a process. Likewise, if you are creating a thread at a faster pace, then you can also destroy that thread at a faster speed than a process. Switching between two threads takes less time than switching between processes. Now context switching is what happens between processes, but it takes much less time in the case of switching between two threads. Threads enhance efficiency in communication between programs. What the function the threads perform is that they enhance the communication between two programs. Now threads use in a single user system. What is the use of a thread in a single user system? Number one, foreground and background work. Asynchronous processing, speed of execution, modular program structure. You can perform foreground work as well as background work. You can perform asynchronous processing, and speed of execution increases. Modular program structure is there, where the complete program can be divided in different modules. Now in an operating system that supports threads, scheduling and dispatching is done on a thread basis. When we are using an operating system which is making use of threads in place of processes, then scheduling and dispatching will be done on the basis of threads. Most of the state information dealing with the execution is maintained in a thread level data structures. Suspending a process involves suspending all threads of the process. Whenever a process gets suspended, then all the threads related to the process will be suspended. Termination of a process terminates all threads within the process. Whenever a process gets terminated, all the threads present in the process and all the threads associated with the process will be terminated as well. Now thread execution states. The key states for a thread are running, ready and blocked. Thread operations associated with a change in thread state are spawn, when you create a thread, block, when you block a thread, unblock, when you unblock a thread, and finish, when the process's execution is finished. Thread execution. A key issue with threads is whether or not they can be scheduled independently of the process to which they belong, or is it possible to block one thread in a process without blocking the entire process? If not, then much of the flexibility of the threads is lost. The main issue, the key issue which arises with threads is that can they be scheduled independently of the process to which they belong, or is it possible that when we block one thread in a process, we don't have to block the entire process? If not, then much of the flexibility of threads will be lost. Now, RPC using single thread. This is the diagram of an RPC where we are using a single thread. This is process 1, and here RPC request is being RPC made, which is being further processed to server, and then in this diagram you can see we are doing the RPC using one thread only. Now here you can see RPC using one thread per server. Each server has one thread. Thread A, this is the this is process 1, thread B, this is process 2, and here you can see RPC request is being made, which is further being sent to server. Now here you can see this is the blocked or waiting for response to RPC state. Whenever we are showing these this type of figure, this type of pattern is there, then it depicts that the thread is blocked or waiting for response to RPC. Then when there is this type of pattern, then blocked waiting for processor, which is in use by thread B, and green signifies running state of the process or thread. Now multi-threading on a uniprocessor. Here you can see that this is process 1, this is process thread A, and this is process 1 of thread B, and this is thread C. Similarly, here you are using single processor, uniprocessor, and multi-threading is being performed. How is it being performed? Input output request is being made at thread A process 1, and then when the request gets completed after the blocked state, right? Now let's get to know something, a little bit more about thread synchronization. It is necessary to synchronize the activities of the various threads. All threads of a process share the same address space and other resources. Any alteration of a resource by one thread affects the other threads in the same process. Now what we have to, it is very important for us to synchronize the activities of the various threads. We have to synchronize the execution of the threads. Now all threads, whatever threads are present of the process, will share the same address space and the other resources. Any alteration of a resource by one thread will affect the other threads in the same process. Whenever a change is being made to one resource by a thread, then the other threads will make the similar changes in the process to that particular resource. Now type of threads, let's get to know about the type of threads. Threads are of user level threads and kernel level thread. We are talking about threads for user processes. Both user level thread and kernel level thread execute in user mode. So what I am trying to say is that both of the threads will execute in the user mode, and operating system may also have threads, but that is not what we are discussing here. Now let's know something about user level threads. Thread management is done by the application. The kernel is not aware of the existence of threads, not the kind we have discussed so far. So this is your user space. You must all be aware about of the user space and the kernel space. And thread management is done by application. The kernel does not know that the thread exists. Okay. Now relationship between user level threads and states and processes states. Now here you can see in 4.6a and 4.6b. Here you can see thread 1 is ready, and then it gets in the running state, then it gets blocked, then it again gets again the cycle continues and it moves to the ready state. Similarly, same kind of process happens to the thread 2, and same kind of procedure happens in the process A. And similar, these are the example of relationship between user level threads and process state. See, whatever happens in a process, in multiple threads in a single process, the same cycle repeats in the complete process. Okay. Now, what are the advantages of user level threads? User level threads can run on any operating system. Scheduling can be application specific. Thread switching does not require kernel mode privileges, no mode switches. So you don't need a particular operating system to run user level threads. It is platform independent, and scheduling can be application specific, can be specific to your application. Thread switching does not require kernel mode privileges. That means that there are no mode switches. Disadvantages of your user level threads are, in a typical operating system, many system calls are blocking. As a result, when user level thread executes a system call, not only is that thread blocked, but all of the threads within the processes are blocked. Whenever a user level thread executes a system call, it is not that the only thread is blocked. All the threads which are present in that process gets blocked. In a pure user level thread strategy, a multi-threaded application cannot take advantage of multiple processing. How to overcome user level thread disadvantages? Jacketing is a process which converts a blocking system call into a non-blocking system call. Now you can write in using jacketing, what we can do is we can write an application as multiple processes rather than multiple threads. Kernel level threads. Thread management is done by the kernel. We could call them kernel management threads. No thread management is done by application in unlike user level threads. In kernel level thread, the thread management is not done by the application. For example, Windows. See here, this is your user space, that is your kernel space, and the process is executing different kind of threads. What are advantages of kernel level threads? The kernel can simultaneously schedule multiple threads from the same process on multiple processes. The kernel can simultaneously, what it can do is that it can schedule multiple threads from the same process on multiple processes. If one thread in a process is blocked, the kernel can schedule another thread of the same process. Now, what are disadvantages of a kernel level thread? The transfer of control from one thread to another within the same process requires a mode switch to kernel. Now, this is the operation null fork, user level threads, kernel level threads in processing. Thread in operation latencies in microseconds it is depicting. Combined approaches. Thread creation is done in the user space. Bulk of scheduling and synchronization of threads is by the application. For example, a Solaris. Now, relationship between threads and processes. Now, threads and processes is a one-to-one relationship. How? Each thread of execution is a unique process with its own address space and resources. Example, traditional Unix implementations. Now, let's give an example of a thread to process many-to-one relationship. A process defines an address space and dynamic resource ownership. Multiple threads may be created and executed within that process. in any single process, multiple threads can be created. So that is why we can say that it is a M to 1 or multiple to 1, many to 1 relationship. For example, Windows, Solaris, Linux, OS2, OS390, Mac. Now, how can we say that thread to process is a one to many relationship? Since a thread may migrate from one process environment to another, this allows a thread to be easily moved among distinct systems. A thread migrates from one process environment to different processes, and that is why we can say it can be easily moved among distinct systems. For example, RA, Clouds and Emerald. A thread to process is a M to N, many to many relationship. How is it explainable? How can you justify the fact that it is a many to many relationship? Since a thread combines attributes of a many to one and one to many cases. For example, tricks. Multiple cores and multi-threading. This is a topic that I want to keep it for the next lecture, and I will explain to you this topic in the next lecture. So please go through the PPT, and if there are any kind of questions you want to ask me, then you can put them in the comment box and I will try to answer your queries. And thank you so much. Thank you very much.